Okay, this will walk you through doing the matrix inverse for a simple 3 by 3 matrix. We have this 3 by 3 matrix, 6, 0, 4, 0, negative 1, 2, 1, 2, 0. The way I do this is I set up the matrix next to an identity matrix. We can do that with one line of MATLAB code where we make a 3 by 6 matrix. So we have the original matrix here, and we have 1, 1, 1 here. So this represents basically 3 sets of equations. Now to do a matrix inverse, we want to manipulate these equations so that we get 1s on the diagonal and 0 everywhere else. So the first thing is to get a 1 here where this 6 is. So if we do that, we multiply the first row by 1/6. So now 6 times 1/6 is 1. 4, 6, 1/6, all the way across the first row. The procedure goes down the first column trying to get zeros below the diagonal. There's a 0 here, so we won't have to do anything. But we want a 0 in this 3, 1 element. So to do that, we can subtract row 1 from row 3. So row 3 is equal to row 3 minus row 1. If we do that, we should get a 0 there. Now this first column is taken care of. Next, we go to the second position, the 2, 2 element. We want a 1 here, so let's multiply that second row by negative 1, so it flips all the signs. Negative 1 goes to 1, 2 goes to negative 2, 1 goes to negative 1. Now we have a 1 in the zeros in the first column, a 1 here, but we need zeros below that value. So we have to clear out this bottom position here. So let's subtract from row 3 2 times row 1. We're using row 2, we're using row 2 because if we do anything with row 2, the 0 means it's not going to mess up anything down here. And this is this 1 is here to knock out the 2. So when we do that, we end up with a 0 in that 3, 2 position, row 3, column 2. 1 on the diagonal, 0 below. 1 on the diagonal, 0 is below. We need to get a 1 here in the 3, 3 position. So all we have to do is multiply row 3 by 3/10. So now we have 1s on the diagonal. If we were doing row reduction, we'd be done. But to get the matrix inverse, we have to get the values above the diagonal to be 0 as well. So let's start with a third column, knock out this guy. We're going to use row 3 to knock out the third column. So row 3, if we add 2 times row 3 to row 2, the zeros won't mess around with any of this other stuff, but this 1 will knock out the 2. So we can do this line, add this row to this value, that gets rid of that value. We still have a 0.66 up here, so we have to use the third row again to knock out that 0.66. We're going to eliminate that 1, 3 element by subtracting 2/3 of row 3 from row 1. And it looks like we're done. If there were something here, we'd have to use row 2 to get rid of that element, but there's not. So we're actually done. We have 1s on the diagonal, 0s above and below. So whatever's over here in this 3 by 3 over here should be our matrix inverse. So we can grab those values, 0.2, negative 0.4, negative 0.2, those values. Do we know if we found the matrix inverse? We can multiply it by A. It looks like it's pretty close to the identity. And the inverse matrix, you can also swap it around. A inverse times A is the same as A times A inverse. And it looks like it gives us pretty close to the same answer that MATLAB would give us. So that's one way of doing a matrix inverse using MATLAB so that you don't make mistakes with the algebra and you can show all the different steps.